Okay, our next speaker is Mark Snyder, and he's going to talk to us about concrete pavement reuse and recycling. So let's welcome Mark. Thank you.
Thank you. All right. Well, here we are at the National Pavement Preservation Conference, and we're talking about concrete pavement recycling, which I don't think is really pavement preservation. So I figure I must be here as a result of some FCC equal time rule or something like that. Something for the concrete industry. And I'm hoping this will be a really good presentation for you. I'm, in fact, hoping maybe it'll even get a recognition by the Nobel Committee, because I figure if Bob Dylan can get recognition for lines like, everybody must get stoned, you know. You guys see that today? Bob Dylan got a Nobel. Wow. Yeah, now and I'll go home. That's great. Okay, so concrete pavement reuse and recycling. What is concrete recycling? Does even the laser works? Okay. Concrete recycling. Taking old hardened concrete and crushing it down to produce aggregate, basically is what we're doing. So you can see we're really not preserving the pavement unless you talk about maybe the option of preserving the underlying pavement structure and building a new pavement on top of it using perhaps some of the materials that are produced by recycling the concrete. Noting that it is saying that it's concrete from an acceptable source. And we got a couple of different sources shown here. You got, this is concrete that came from a concrete pavement. Lots of slabs there. It looks pretty clean. Here is demolition debris. You can see there's a lot of concrete materials there. There's also brick, there's mortar, there's gypsum, there's all kinds of other things there. Both are recycled into different streams and can be successfully recycled. But typically for highway paving, we've got pretty stringent requirements, at least on recycling back into mixtures of various sorts. We tend to be sticking to things that we know the quality of, we know the background and the history of, and that would be the concrete pavement materials there. They are 100% recyclable concrete pavements, just as the asphalt pavements are. I think people overlook that a lot of times. Even the fines are recyclable. We're finding a lot of uses for the fine materials now that didn't used to be out there in the past. Those uses for both fine and coarse material include the things that you see here. Obviously, far and away the biggest use is back into base layers, taking the material, crushing it down, and using it as an aggregate base. Far and away the most common thing that's used, because it's relatively insensitive. We can use this material back in a base really without worrying too much about some of those other contaminants like the brick and the gypsum and the mortar and even asphalt materials and things like that that might also be included in the concrete at the time of recycling. But we also see some higher type applications, see it being used back into new concrete mixes, both in single lift conventional concrete paving construction, as well as in two-lift paving construction. We're seeing a lot of interest in using crushed concrete as the aggregate in the lower lift of a two-lift concrete paving system. I'll show you that a little bit later. Actually, more of it used in asphalt concrete than there is back into concrete mixtures. A little higher demand for the asphalt typically because the concrete tends to be fairly highly absorptive, so the asphalt demand goes up a little bit, but it is used. Used as backfill, used as riprap like you see here for erosion control, and a lot of other applications as well. I've seen it used as filter materials, as turkey grit for some of the fines. We're seeing it used a lot of different applications. It is a proven technology. Again, used in a lot of different states. FHWA did a survey about 12 years ago, surveyed all the states. Most of the states responded. A couple of them up there in white did not. At that time, there were 41 of the 50 states that did allow recycled concrete aggregate in the specs in different applications. That's 12 years ago. I know for a fact that Missouri uses it now and has for the last 10 years. I'm pretty sure I drove through Montana this summer on the way out to Yellowstone National Park, and they were recycling portions of I-90 out there. So this map's a little out of date. It may be significantly higher than 41 now, but a lot of states using it in one application or another. And why are they doing it? Well, sustainability, one leg or another of the sustainability triangle there, I think really defines an awful lot of the reasons, for the same reasons that the previous speakers talked about. Conservation of resources. If we don't have to go in and mine out new aggregate materials, if we can use the existing materials, which often contain very, very good aggregate, we're saving the existing materials, we're saving the cost of mining and producing those materials, we're saving the fuels that are consumed in the mining and the hauling and the crushing of those materials, and all that turns back into economics, which is a lot of times a big driver for many of us. Saving money, obviously. And then, of course, the reduction of greenhouse gases, which goes with the reductions in the consumption of energy. So lots and lots of reasons for recycling, but they can all kind of be lumped together into sustainability, I think. Another aspect of sustainability is longevity of performance. And we do see that there are some potential performance improvements even from using recycled concrete materials in various applications. In the foundation applications, we are finding, many states have found that the crushing of the concrete exposes previously partially hydrated or unhydrated cement grains, such that when you lay this material out with those freshly exposed grains out there, and then over a period of time, water infiltrates the pavement system and causes those grains to rehydrate or to do additional hydration, we see some stiffening of that base. So you actually have a stiffer base for the same gradation of a recycled material as you would with a natural aggregate foundation material. And that can take that can provide some benefits in terms of perhaps reduced thicknesses required for the layers that go above that base layer. You also have a very rough surface texture and an angular nature of the product, so you get very, very good grain interlock in that foundation as well. There's also been a few studies that have shown that when you use it back into concrete materials, particularly the fines, maybe not so much the coarse aggregate, but limited amounts of concrete fines, maybe up to 20-25% replacement of fine aggregate, will actually improve the strength of the concrete. A little higher strength than the compressive strength of the concrete that results. Maybe partially that it's a different size material. It kind of fills in a gap in the gradation that we don't normally see when we're using natural sands and natural coarse aggregate. The recycled kind of fills in a gap there, which gives us a little denser packing maybe of the aggregate particles. Not sure really what the mechanism is, but it's a genuine effect. So the two key uses we have: unstabilized subbases and backfill materials. Again, the most common application in the U.S. At least 39, 40 states that I know of are using it currently. And as I said, a lot of folks think that it is better than using natural aggregate in many cases because of that secondary cementitious action. And it's fairly easily implemented because some degree of contaminants, considering joint sealant materials and asphalt, perhaps not contaminants per se, but not pure concrete, let's say, is tolerable. And fortunately, it's been pretty well implemented already. There is an AASHTO specification. M319 covers the AASHTO recommendations for using crushed concrete in subbase materials. There have been some NCHRP studies done recently as well. One that was completed here about 8 years ago by Attar Saeed and Mike Hammonds developed a series of quality requirements for different uses of crushed concrete in bases. And they developed a series of tests, the micro-Deval test. They didn't develop the test, but they adopted those tests into a matrix that said that if you have a certain level of traffic and a certain environment that you're constructing in and a certain moisture condition, freeze-thaw climates and moisture condition, then these would be the requirements for each of these tests that are listed here. And again, the lower applications, lower functioning applications such as farm to market roads or county roads, things like that, where it's really not a critical application. The requirements for all of these are much less restrictive than if you have a high type pavement like an interstate, urban interstate pavement. And of course, crushed concrete can be graded just as you grade normal aggregate according to the needs for the subbase function, whether it's going to be a free draining material or whether it's going to be a densely graded material. And there is an American Concrete Pavement Association engineering bulletin. It's all about subbases, and it addresses the requirements for free draining and dense graded crushed concrete aggregate. So would direct you to contact your local ACPA representatives for copies of that publication. It's a very good publication. In terms of structural design, again, the fact that the material will stiffen in that subbase can be a good thing in terms of having reduced thickness requirements on top, but it's also something we need to keep an eye on, because if you have, for example, a stiffer subbase and you're building a concrete pavement on top of it, your curling and warping stresses tend to increase, and your frictional stresses between the slab and the foundation may be a bit higher. And those may necessitate that you would adjust the thickness of the pavement accordingly, or maybe you're going to shorten up your joint spacing to reduce your curling and warping stresses. So it's always something to take a look at. Modify the expected foundation support values and take a look at the stresses in the pavement before you do your final design. There have been no structural problems, however, reported with the use of crushed concrete in these foundation layers. It's all been on the positive side from a structural standpoint. Now, there have been some issues with drainage, And what we have happening here is that, along with having possibly unhydrated cement grains, we have a lot of dust that's produced in the crushing operation. And in addition to the dust, which we'll call insoluble residue, in addition to that, we may also have calcium hydroxide present in the cement itself. Okay, and calcium hydroxide, very soluble in the presence of water. So if you run water through that and you leach that calcium hydroxide out, it goes into solution. Calcium ions go here, hydroxyl ions go there. Hydroxyl ions contribute to a relatively high pH value that you get. And the calcium ions will combine later on with atmospheric carbon dioxide, and you get calcium carbonate, limestone, essentially precipitating out. So between the dust and the calcium carbonate, if you got a lot of water flowing through, you can have clogged drain pipes. And what this is here, this is a drain outlet, and the entire rodent screen here is all caked over with calcium carbonate precipitate, and someone just jammed a rebar, poked a hole in the end of it, and the water is running out. That's not a good thing, obviously. If you clog up your drainage system, you don't have a drainage system, you got a moisture retention system. Okay, we don't want that. Here's a picture from this is from just down the road from where I live in Pennsylvania. You can see a little bit of stuff. This is after just 1 year. You can see a little bit of stuff down in the bottom. This is after 6 years of a different project, and that pipe is about halfway full. It's still flowing water. Okay, and as long as you're flowing water and moving the water out of the system, it's not an issue. But we have seen incidences like this here where you are clogging the entire system and holding water in. So as long as we use the recycled concrete in an undrained layer or below the drained layers, we don't have a problem at all. But there are also techniques for preventing that from happening when we're using it in a layer that is drained. There's a lot of different approaches here that have different degrees of efficiency. First of all, minimizing the use of the fines, reduce the surface area that you can run water over, and you reduce this kind of a problem. You're not dissolving as much dust and calcium hydroxide out of those particles. So get rid of the fines. Make it a little bit more open graded. Use larger top size aggregate particles. You can even use impact crushing processes to pretty much get rid of the reclaimed cement part. Use those elsewhere and just get back to as close to a natural aggregate condition as you can. Reclaim the original natural aggregate. Blend crushed concrete and virgin materials. Again, large top sizes. Consider washing the material. Yeah, adds another expense, but have seen some states go to that, washing the crushed concrete. Using fabrics that have a very, very high permittivity, so that if they do get a little bit of clogging on there until the situation stabilizes, they're still going to carry water. Wrap the trench instead of the pipe. What we saw early on, 20, 30 years ago, people were using fabric wrapped pipes. You remember that? And of course, that concentrates all the dust and stuff in a very small area. If we wrap the trench rather than the pipe and allow the water to flow into the pipe, we eliminate the clogging at the source there. And then finally, probably the easiest thing what ACPA recommends is just to daylight that subbase. Forget about the pipe. Run that all the way out to the foreslope of the shoulder and drain it out there, and then you eliminate that problem as well. So lots of different techniques for getting around those drainage issues. The other key use is in concrete mixtures. Been used in concrete mixes in the U.S. since the 1940s. I think the first one was actually on Route 66 back in the 1940s. Can't remember where the section is. It was in Oklahoma or in Missouri. It was one of those two, I think. But we can use crushed concrete as the primary aggregate source or even as the only aggregate source. In this picture here, I'm going to show you another bit of detail on this. This is Houston, Texas, Interstate 10. This is all crushed concrete, the sole source, both coarse aggregate and fine aggregate. It's uncommon because the fines tend to make the mix kind of harsh, but it can be done if you got a patient contractor and a good mix design. We're seeing a lot of use in it. Two-lift pavements, as I said. It's been a standard practice in Europe, particularly in Austria, for more than 30 years. They put it in the lower lift and put a high-quality, high-friction aggregate in the top 2 to 3 inches or so. And we're seeing some work being done here in Illinois, and the Illinois Tollway actually has adopted the use of two-lift paving on a wide-scale basis, as we'll show here in a second as well. When you're doing it into concrete mixtures, pretty much conventional batching, mixing, delivery, placing, finishing techniques. We may need to mix up the design a little bit. Our proportions may be a little bit different because given that you've got the more angular, rough textured nature of the particles there, it's going to be a little bit harsher mix to work with. So to address that, we can eliminate or limit the amount of fines that are used. Again, holding it down to 20-25% fines if they're used at all. Seems to work pretty well. Pre-soaking it so you don't draw a lot of water out. Again, the crushed concrete is a relatively absorptive material. A little higher absorption capacity than conventional aggregate. It's going to suck water out of the mix, which tends to make it stiffen early. So if we pre-soak it, use the aggregate in a saturated surface dry condition, that eliminates those problems a lot of times. Chemical and mineral admixtures, obviously, fly ash, water reducers, high-range water reducers, plasticizers, etc. Those will all help those problems as well. And the other thing we need to be aware of is that the properties of the concrete that we produce from recycling are probably going to be a little bit different. They're often a little different from conventional concrete if everything else is the same. If you don't change any mix proportions, you don't modify the materials that are used in the batching process. From a structural standpoint, we also need to consider the impact of the behavior of the concrete on the design of the pavement. Typically have a little higher coefficient of thermal expansion and contraction, typically have a little higher shrinkage coefficient, which might mean maybe we need to adjust the panel lengths, bring those down a little bit. Maybe we need to adjust our sealant reservoir dimensions if we're sealing our joints. If you got a little more movement taking place, you might need to have a little wider reservoir on your sealant so that it accommodates that movement. Might want higher reinforcing quantities slightly in your continuously reinforced and jointed reinforced pavement. Okay, so those kinds of things. There are also recommendations for using concrete in the mix designs. We have a provisional specification, MP 16-13. Basically, quality requirements and properties, pretty much the same as for conventional concrete. The states that have specifications for using crushed concrete in their concrete mixtures basically don't waive any of the quality requirements, and they shouldn't, with the exception of the sulfate soundness test. Got to find a different way to evaluate freeze-thaw durability because the sulfate soundness test is not reliable for crushed concrete. Also want to mitigate if we have any materials related distress in the original concrete that's being recycled. For example, if you have ASR or if you have decracking, we need to take action to mitigate those in the mix design as well. Adding Class F fly ash, slag cement, limiting the amounts of fines, again cutting the surface area back, and then making sure we've got drains and joint sealing to keep the water out of the system, because ASR, like decracking and many other distresses, needs water to help kick things off. Same thing for decracking. Reduce moisture exposure, and also cut the aggregate top size back so that if it does have a little bit of expansion capability, it's doing it over a smaller particle size, which is not as disruptive. Been very successful in general with reducing coarse aggregate size down to 3/4 inch minus. In the proportioning, you got a different specific gravity. You got mortar that's clinging onto the aggregate particles, so your specific gravity is going to be lower. You can't batch things based on weight now. You got to look at the volume and get a new weight for your aggregate when you're using recycled materials. And the absorption capacity will tend to be a little higher as well. May have a little more variable strength. And to maintain workability, chemical admixtures, mineral admixtures. Some folks like to just add a little bit of water, but if you add water, you got to add cement too, because you don't want to change your water-cement ratio and make the mix less strong or less durable. So these are all different approaches for the proportioning. Also want to verify your air content requirements. Sometimes if you got a lot of air in the old mortar and you got a lot of reclaimed mortar, your air pot's going to pick up that air and count it as total air in the system. So if you really want 5%, 6%, 7% in your fresh paste for durability, you may have to bump your requirements on the total air content up slightly, or else use a rollometer to do it instead of using a pressure meter. Okay, performance of pavements constructed using crushed concrete. They're generally been pretty good. There have been a few notable failures, pretty well publicized failures. Saw Andy Bennett here. Michigan had some of those back in the 80s, and there have been a few others. Kind of tracked down what was going on. We were learning at the time, learning about the panel lengths and panel spacing and a lot of other things. There were some design issues on some of those projects. But I think that the general consensus today is that you can use crushed concrete in new concrete mixtures as long as you pay attention to the details and what we've learned from those failures back in the 80s. We should expect good performance now. And here's a few examples. I mentioned this Texas I-10 project between I-45 and 610 West Loop. Originally constructed reconstructed, I should say, in 1995, 6 center lane miles. The original pavement was built in 68, so it's 27 years old. 10 lanes, plus high occupancy vehicle lanes. Here was what the original pavement looked like. It was continuously reinforced concrete on a cement stabilized base. They had two different sections out there. They reconstructed it into 14 inches of CRC, over 3 inches of asphalt stabilized base, and 6 inches of lean treated base, and then 11 inches of CRCP overlay over a 1-inch bond breaker. Two different sections all coming from this same section, and they used all recycled materials, all crushed concrete, coarse and fine materials. This picture was taken almost 10 years ago now. It looked great then. Talked to Corey Zollinger with Cemex. He lives down in Houston. He said he drives it every day. Still looks great now. So just about 20 years old now, 21 years old. 100% recycling. Clearly a success story on very, very high volume traffic. The Illinois Tollway, as I said, is doing a lot of recycling. 32 miles of the Interstate 88 extension, which is west of Chicago, was rubbleized in place. Okay, talk about transportation savings, taking and rubbleizing that material in place and using it in place as a base for the placement of a new concrete pavement on top of it. And then they've had the Move Illinois program over the last 8 or 10 years now. They've done some additional recycling of the concrete into base. And they've estimated recently, Steve Gillen was estimating they've saved about $20.5 million just on the materials cost, $25.5 million in hauling it, 500,000 gallons of fuel, and 12 million pounds of CO2 not emitted by recycling the concrete back into base layers. So there's all that sustainability coming back into play there. A couple of quick examples of recycling damaged pavements. The decracking example, I mentioned US 59 in Worthington, Minnesota. Ben's neck of the woods there. This was the first major recycle of a decracked concrete pavement in the United States. 16 centerline miles, originally built in 55, reconstructed in 80 because it was really badly decracked, so freeze-thaw durability of the aggregate. Used all the coarse aggregate, 3/4 inch top size in the new pavement, took the fines and put a 1-inch cap on the existing subbase, and of course that's going to solidify up then with a little bit of moisture and give you some additional support. They did add edge drains to get the water away, keep the pavement's feet dry. Not terribly heavy traffic out there. It's out in a very rural area, a lot of pig farmers out there hauling livestock to market. But the big thing is there's been no recurrent decracking. They kept waiting for this thing to fall apart, and it never did. Finally, in 2000, went out and rehabbed it again. This is a picture I took in 2006 when I was out there. They diamond ground it off. They retrofit dowel bars because there weren't dowel bars put in the original pavement, so it faulted pretty badly. But MnDOT estimated at the time that they saved about 27% of the project cost by recycling and about 150,000 gallons of fuel. So again, clearly a success story. Still looks good today, Ben. You been out lately to Worthington? No? No? Haven't been out to the Pig Fest or whatever they have out there? No. Pheasant Fest, okay. Alkali silic reactivity, I-80. In a large portion of I-80 in Wyoming had a lot of bad ASR reactivity. Reconstruction in 1985 of some portions near the Nebraska border used 65, they had a lot of ASRs. They were really covering their bases here. We're only going to use 65% recycled, 35% natural, 22% recycled fines. They used low alkali cement. They used Class F fly ash. They kept their water cement ratio down. Very heavy traffic, as you'd imagine, out on I-80. In 2004, again, they built it without dowel bars for some reason. Had to do a rehab, diamond grind it, dowel bar retrofit, joint resealing. You can see the traffic doubled between 85 and 2006, still 30 to 40% heavy trucks. I hear they're just now starting to see some, they've started to see, have we got anyone from Wyoming out here? Anyone from Wyoming in here? I've heard a rumor that they're seeing some ASR out there now coming back. 30 years later, I think that they've achieved their mission. It didn't come back. They got more out of the reconstruct than they did out of the original construction. And we'll see what comes as this stuff recurs going forward. But I think it's still clearly a success story. Production of crushed concrete. Typical steps are shown here. And I'll hit these each very briefly. Evaluating the source concrete. What have I got out there? What do I feel comfortable using it for? You know, if I got something like this where I've just got, you know, a few cracks periodically and some spalling, maybe the pavement's reached the end of its service life from a cracking standpoint, but there's no materials problem here. I have no problem using that for recycling into any application. This is a CRC pavement. You expect lots of cracks. Maybe this is more than they expected, but again, it doesn't look like there's any durability issues. This is decracking. Maybe this one I don't want to put back into a new concrete pavement, unless I'm in Minnesota and they got a good handle on it, you know, or some places. But the point is here, you make that decision about what you've got and where you feel comfortable using it. Pretty much anything folks are comfortable putting back into a base or back into fill applications and things like that. This may give you a little pause and make you think about how you're going to use that going forward. Then there's the whole issue of known sources versus unknown sources. A lot of states have got specifications for using recycled materials. A lot of times they're requiring that they be from the pavement that's being reconstructed at that time. If you have an open spec, you want to have some kind of a quality spec on there about where that material is coming from and being able to trace it back, because there are potential problems with building and demolition debris, with using brick, with using gypsum, and other sorts of contaminants that might be present, even into base applications, particularly into paving applications. So know your sources, know where it's coming from, and have a good handle on the quality. In terms of the pavement preparation, prior to recycling, again, usually not too much for going back into a base course. If you're going to use it into concrete mixture, maybe a little bit more work necessary, or desirable at least, getting rid of the joint sealant using a cutting tooth plow of the type that you see here. Taking it out during the production process, simply beneficiating, removing that material after it's been crushed down. Removal of the asphalt patches and overlays and shoulders. Again, we used to require this routinely. Back in the 80s, Iowa did some concrete recycling back into concrete pavements, and they had allowed 30%, I think, asphalt to be recycled back in. And with the air and training admixtures that they were using at the time, they had a hard time controlling the air content of their mix, because there's some kind of a chemical interaction going on between the air and training admixtures and the recycled asphalt that was present. Today's modern admixtures, we don't seem to see that sort of a concern, and as a result, again, we see a lot of European countries, Austria, Germany, allowing up to 30% RAP in their concrete mix, particularly in two-lift construction. And Illinois Tollway, for example, is actually specifying and allowing the use of what they call fractionated recycled asphalt paving. It's the coarser asphalt particles. They're taking the fine stuff, which has got the higher asphalt content, using that back into asphalt applications, but the coarser particles, they're putting that back into the lower lift of two-lift paving, along with, if the contractor desires, along with crushed concrete aggregate as well. So lots of use of recycled materials that way. The breaking processes, the main purpose of breaking the material is either to size it for ease of removal and handling, typically 1.5 to 2 foot top size. Also helps to break the stuff away from any steel that you might have in place there, particularly if you got CRC or jointed reinforced pavement. We see these guillotine hammers and impact hammers being the most common approach. Do see, if we're rubberizing it in place, the resonant pavement breakers like you see there, and you can get 1,000 square yards per day or more out of the drop hammers, and quite a bit more than that out of the resonant breakers. So pretty good production. Pavement breaking and removal now, using the rhino horn to kind of loosen those pieces that have been fractured and broken out. End loader to put it into the truck and haul it to an off-site place, or doing it right on the job site. And we're seeing a lot more in-place recycling of concrete being done now, where you got basically a portable crusher being used. The stuff's been broken up, using a backhoe to drop it into the crusher here, and a couple of different windrows being set up, one for coarse material out to the right, and you can kind of see one for fine material going out to the left. Windrowing those off to the sides and using them on the job site as required, usually back into a base application. If you have steel that's needing to be removed, particularly if you got continuously reinforced, a lot of steel there, that's often best broken up in the field there. Get guys out there with the cutting torches and the pneumatic shears, cut that and remove as much as you can. Whatever doesn't get removed can be removed after it drops out the bottom of the crusher. Really the only modification to the crusher in that case is to drop your belt down a couple feet, so that any rebar that comes through can turn the corner without poking a hole in your belt coming out of the crusher. That kind of ruin your day. So removal by hand, you can see them pulling the stuff off, or with an electromagnet, as you can see here, and depositing it down on the side. And that again is another recyclable material. Usually we find that the cost of recycling that steel pays for the cost of doing the removal, and maybe a little bit more. You can use standard crushing and sizing equipment. Mainly we got jaw crushers, cone crushers, impact crushers, typically a two-stage process, a primary crusher and a secondary crusher. What you really want to do is specify what you want that gradation to look like and let the contractor figure out how to crush it, because there are different gradations of materials going to be produced with different crushing processes, and even with different aggregates and different mix designs. You get granite versus limestone versus gravel those different aggregate types, cement will tend to bond to those different aggregates differently, and you'll get different reclamation efficiencies out of those. And using different crushers on the same aggregate. An impact crusher is going to tend to give you a finer grain distribution. More fines is going to tend to remove a lot more mortar. The jaw crusher is going to tend to give you a coarser particle size distribution. So you'll have a higher reclamation efficiency and fewer fines being produced. So figure out what it is you need for the project, specify that, and let the contractor figure out how to produce that material. Recently, we've seen just within the last several months here, the EPA coming down on silicosis in construction, and obviously that's had an implication for sawing concrete. It also has an implication for crushing concrete as well. So we're starting to see now the contractors are putting these dust suppression systems like this sprayer here on their concrete crushing processes to help hold that down. Asbestos could be a concern if you get demolition debris. Hopefully we're not putting any asbestos aggregate into our pavements, so it shouldn't be a problem there. Beneficiation means we're trying to improve the properties of the material prior to its further use. Examples would be getting rid of any organic material. You're out there picking up the slabs. Maybe you picked up a little bit of dirt along with it from the soils underneath there, excessive dust, other kinds of contaminants. Depending on the application, you may or may not need to get rid of those through some beneficiation process, such as washing, wet or dry screening, air blowing, heavy media separation. All kinds of techniques can be used to improve the quality, the nature of the material after the crushing process. And obviously what you need to do depends on how you're intending to use it and what the original condition and composition of that material is. Stockpiling, basic procedures are the same as for natural aggregate. A couple of additional caveats: when we're stockpiling fine materials, you stockpile a bunch of fine material out there, you can have secondary cementing take place there. When rain falls on it, you may get a crust forming on the outside, and now you don't really have all fines there. You got to kind of break through that stuff, and that stuff's not the fine material you wanted. So some folks, you want to protect those stockpiles from moisture, tarping them, building temporary shelter, etc. And with any recycled concrete aggregate stockpile, the runoff initially is going to tend to be fairly alkaline. Okay, that same calcium hydroxide leaching process I told you about before, until that stuff has been leached out and dissolved out of the surface of those aggregate particles, you may see runoff pH that's up in the 11Z, 12Z, 13Z area. Okay, pretty high pH. So you want to collect that and not let that run off where it may cause an environmental issue. That does tend to decrease again as you consume the calcium hydroxide. That will stop and go away. Properties of the concrete, again, this is looking at absorption capacity for virgin materials versus recycled materials, and this is assuming you've got recycled crushed concrete, coarse aggregate only we're talking about here. You can look at the numbers yourselves here. Obviously it's going to be a bit higher than you have with natural aggregate because of the fact that the mortar itself has a higher absorption capacity than most of the aggregates do. Since we got mortar and concrete together, or mortar and aggregate together, mortar has a relatively low specific gravity. We're going to tend to see combined particle specific gravities that are lower than that of natural aggregate as well. Our LA abrasion numbers may tend to be a little higher, but still generally acceptable with most state paving specs for what the LA abrasion numbers need to be. And the chloride content can be any number of values here, depending upon where you're getting the material from and whether you're looking at coarse materials or fine materials. If you're from a northern state and you're looking at something that contains a lot of fines, particularly from near the surface, where the chlorides have been absorbed over the years from the de-icing chemical application, you may see some pretty substantial chloride numbers there. If you eliminate a lot of the fines, that tends to drop down to much lower numbers. If we look at the properties of concrete that's made using crushed concrete aggregate or recycled concrete aggregate, as the slide says, it's all about the mortar. Here's a recycled mix. This is from one of the jobs in Minnesota. It might even have been the job we were looking at there. No, it's not. This is from one of the ones on Interstate 90. But anyway, you can see smaller particle size. This was crushed down to 3/4 minus. Again, they had a slight decracking concern, so they crushed it down to 3/4 minus. This one, you can see larger particles here. If you look at this one, you can also see mortar. Some of it's kind of dark colored, and some of it's kind of lighter colored. The lighter colored mortar is the reclaimed mortar. But the total mortar content over here is much higher than the total mortar content over here. And as a result, you're going to tend to see higher absorptions higher shrinkage values, higher creep values if you're in a structural application, things like that. So you have to treat it like an engineered material. Our properties of our mix made with recycled materials are going to be, again, depending upon what you're using, clean off all the old mortar. It might be pretty close to the same as you have with a natural aggregate mix. If you have a lot of reclaimed mortar, you probably have a little less workability. Finishability can be similar to much more difficult. Tend to have less water bleeding, particularly if we have some fines in there. They tend to kind of clog up the capillary pores for the water to come through. So less water bleeding, more water demand, as we talked about before, and our air content might be a little bit higher because of the entrained air that's already present in the reclaimed mortar. In terms of our hardened properties, again, depending upon how much mortar you clean off and the mortar content, might be anywhere from the same strength to as much as 25% lower if you don't change anything else to compensate. Same thing for tensile strength, a little higher strength variation, a little lower modulus of elasticity, potentially higher thermal coefficient, potentially higher drying shrinkage, and potentially much higher permeability. So these are all things that they aren't necessarily stoppers, but they're things you need to be aware of, need to characterize, and maybe address in the mix design. With lower water cement ratios, for example, to tighten up the pore structure and increase the strength. This is from that Texas I-10 project. They ran 4 different trial batches, and this is their all virgin mix, and they did this all in metric units here, but 28 megapascals is 4,000 psi. So you're between 4,000 and 5,000 psi for everything at 3 days, whether you used all virgin materials or whether you used all recycled materials or whether you used half and half recycled and virgin materials for fine and coarse aggregates. So yes, they were all lower. As soon as you introduced the recycled materials, they were all slightly lower strength, but they're all clearly plenty high enough for concrete pavement construction. Durability aspects really depend on the mix that you use. Freeze-thaw durability, primarily a function of the air void system that you develop in the new mix. ASR tends to be less susceptible because you've probably already consumed a lot of the reacting materials. As you saw in the Wyoming job, it's taken 30 years for it to start to show a problem now, whereas the original pavement was badly failed inside of 25 years. So those are the basic properties. And I think that brings me pretty close to the end here. In summary, we're using this stuff everywhere, particularly in the foundations. It is proven. It is obviously a sustainable technology. I think that the key to successful use is to treat it as an engineered material and test it very thoroughly to know what you have and to make the appropriate adjustments in your use and in your structural designs and so forth. And again, in general, performance of Pavements Constructed has been recently, it's been excellent recently, and historically it's been generally good. ACPA has an engineering bulletin on recycled concrete pavements. It goes into much more detail in all of these areas here than what I did, and the appendices include guide specifications for use, so I recommend that highly. The National Concrete Pavement Technology Center developed a deployment plan to aid states in deploying the use of concrete recycling, and that report is available. You can go to the, expect you to copy this down, but Google CP Tech Center and Google Recycling Concrete, and I'm sure you're going to find this. Okay, there's also an FHWA Tech Advisory that's out there. The CP Tech Center also has a number of webinars and things on concrete recycling. In fact, there's one next Wednesday. I think it's Wednesday early afternoon, the 19th. So if you're interested in seeing a little more expanded version of this, go to the CP Tech Center website, and you can sign up for that webinar. It is a free webinar. Finally, I'd like to acknowledge all the folks from whom I begged, borrowed, or stole slides for use in this presentation. A lot of folks there from a lot of different places. And that is all I've got to say about that. All right, well, I appreciate your time and your attention. Thanks very much.